Today we're going to discuss Unit 3, which is boxes and closures. The objectives of this unit are basically, after you study this unit, you should be able to determine the cubic inch capacity of the boxes, both metal and non-metallic, which are the plastic boxes for outlets and for switches, and like install 6 American wire gauge AWG, which is, I'm just going to refer to that 6 gauge wire. I'm not going to mention is American wire gauge because there is a European version, and so we're going to assume the American here in this class. And smaller conductors. You need to know which items are counted when calculating the fill, which are not. In other words, there are some conductors that go through the box that you do not count as a conductor because it's not being spliced or anything like that. You also need to be aware that the two identical switches mounted side by side in a 2-gang box could have different cubic inch volume allowances based on what's going in those boxes. You need to be able to determine the maximum box size, including the plaster ring, extension ring, etc., that is needed if the number of conductors 6 gauge and smaller is known. Again, we're doing the objectives after. You're also going to need to be familiar with the box requirements when using non-metallic sheathed cable. Know the length of free conductor required to be left inside the boxes. Understand that the boxes and conduit bodies must remain accessible after installation, and be familiar with mounting and supporting provisions for boxes and conduit bodies. And then also you'll need to be able to determine the type of box needed for various applications, understand calculation procedures for junction boxes, 4 gauge and larger conductors. You need to basically box fill calculations. Now, metal boxes, I refer you to the table in the code book, and you're going to refer this a lot in this chapter, and I probably have it handy with you at times. I'll have it here in this chapter 1 time, maybe 2 times. I'll refer back to it, but it's in your code book, and you may need it to do some of the calculations that we're going to do for the to figure out the number of conductors that are allowable in a box, or to determine the size of box needed to handle the number of conductors that we have going through there. And then the volume markings on the metal boxes, you're permissible to use these. Where were we? Okay, volume markings on the metal boxes. They're permissible to use even if they're greater than shown in the table. There are some conflicts with the table. They usually are a little more conservative in the numbers of conductors that are allowable, but if the box has written on the box in permanently marked from the manufacturer numbering of the cubic inches of the size of the box, then you can use that number for figuring out your calculations. And non-metallic boxes and additional capacity. These are what you're going to use for your calculations. Now, the box fill calculations, you use the box fill volumes, marks on the box, like I just mentioned, and an unmarked standard box is used to table 314.16 alpha. And it states box fill calculations. That's the heading. The volumes in paragraphs 314.16 B subsection 1 through B subsection 5 as applicable shall be added together. No allowances shall be required for small fittings such as lock nuts and bushings. We'll get into that a little bit down the road. And then here's a picture of the table. This is where you go along and figure out the box size. Now, if you have, we're going to be working with a 4x4 by 1.5 box, square box. So if you're using over here, you've got 18, 16, 14, 12, and 8. That's the conductor size. Now, if we're looking at a 4x4 with a 1.5 inch box depth, and we're using 18 gauge wire, we can have 14 conductors in there. Now, we'll get down into a method of showing how many conductors, basically which conductors can be counted, which ones can't be, when we get further on in this presentation. But if you're using 14 gauge wire, you can only have 12 conductors in there, or let's see, that's 16 gauge. 14 gauge is 10 conductors. As the wire gets bigger, the number of conductors in the box, based on a 21 cubic inch box, which is the size right here. Okay, and we'll do an exercise or two showing, trying to figure those calculations out. And then I think in the test you'll have calculations too. So anyway, we'll get into this. As most of the gauges on wire sizes, as the number gets smaller, the size or the diameter of the conductor gets bigger. Okay, so let's just keep that in mind also. So now that we got that understanding, you know how to read the table and understand how to get the numbers that you need from the table. We'll move on. Now the box volume, again, this is just use that table I just showed you. And again, the box is a 4x4 by 1.5 inch depth size. So the volume of that we already know is 21. Okay, 21 cubic inches. Now we're using basically 12 gauge conductors. So we need to know the number of conductors. And that's going to be 9. It won't show up on this slide because of my picture covering it, but the number is 9. We got that off of the chart. We talked about that a minute ago. And then now the conductor counting, we have to be able to know how to count the conductors and which conductors are added to that number. Okay, so now we'll probably go through the code book and do this. Now I'm going to bring up section B of the conductors. Okay, and essentially what this is the conductor fill. Each conductor that originates outside the box and terminates or is spliced within the box shall be counted once. Okay, and each conductor that passes through the box without a splice or termination shall be counted once. Okay, and now each loop or coil of unbroken conductor not less than twice the minimum length required for free conductors, and this is in 300.14, shall be counted twice. The conductor fill shall be calculated using table 314.16 B. A conductor, no part of which leaves the box, shall not be counted. Okay, and then here's the 300.14. At least 6 inches of free conductor. Each conductor shall be long enough to extend at least 3 inches outside the opening. Okay, what they're talking about, the opening there is the opening of where the conductor enters the box. Okay, and so here's that table they were talking about, the 316B. Okay, so here we have we're using say we're using 14 gauge wire. Okay, over there it's 2 square inches. Each conductor takes up 2 square inches inside that box. Okay, if we're using 12 gauge, it's 2.25. And I think on the example we're using 2.25. So each conductor that we use in the box is 2.25. Okay, now we're getting into different conductors and how they're used within how we count them. Okay, now the pigtails are not counted, but what is counted is like on this is your equipment grounding conductors, the green conductors. They're all coming in from outside locations, and then they get grounded to the box. Okay, that is counted as one conductor. Okay, the pigtails aren't counted, and that's a pigtail. But the conductor B is your equipment grounding conductor, and only count the largest equipment grounding conductor shall be counted. Usually that one's a gauge or two taller in size than the ones coming in. Say they're all 12 gauge, okay? And so you may have a 10 gauge that's connected in there as you're coming out. Where, hold on a second. Okay, I stand corrected. The pigtail, which is option A, is not counted, but the largest conductor in that bundle is what's counted as one conductor. All the other ones. So if you have 14 gauge coming in there, and then you got one 12 gauge, that 12 gauge conductor is the one that's counted. Okay, so essentially it's that's how that one's counted. Right. It has one or more additional equipment grounding conductors, which are your isolated equipment grounding conductors, as permitted in section 250.146 delta or D, shall be counted as one conductor. Under 314.16b subsection 5, when multiple isolated equipment grounding conductors of different sizes enter the box, only the largest is counted. So essentially what that's going to mean is only one conductor will be counted. Pigtail isn't counted, and the other three conductors are not counted if they're 14 gauge, and then you got the 12 gauge coming in, then that 12 gauge would be counted as one conductor. Now, determining number of conductors here, your raceway connectors, hubs, are not counted. Each conductor originated outside the box as a terminated or spliced inside the box counts as one conductor. Okay, the red conductors are counted as two conductors. Okay, they both come in. Okay, this box is pictured contains 5 conductors. If all of the conductors are 12 gauge, the box could hold a maximum of 9 conductors. Okay, it's a 21 cubic inch box, because we already know that, because we figured it out. It's a 4 by 4 by 1.5. In the chart it shows what's 21 cubic inch. So 12 gauge conductors, you can have 9 conductors in that box, I think. Now, a conductor that does not leave the box, such as equipment bonding jumpers and pigtails, is not counted. Okay, that's D. You won't see it behind my picture, but if you're looking at the slides, which I highly recommend while you're doing this, you can follow along. A conductor that passes through the box without splice or termination unbroken counts as one conductor. Each loop or coil of unbroken conductor, not less than twice the minimum length required for free conductors, must be counted twice. This black unbroken conductor is counted as one conductor. Okay. Now, each conductor originating outside of the box that is terminated or spliced inside the box counts as one conductor. That's your F conductor, those white terminals. Again, they're coming in and they're spliced. The pigtail is not counted. And then G, wire connectors are not counted. Your wire nuts are not connected, are counted. Okay. Now, cable clamps and connectors. Now, inside this box down here, you have these clamps. Okay. If you got two clamps inside the box, it's usually a metal box that has these clamps, and they're counted as one conductor. Okay, external cable clamp connectors are not counted. Okay, cable connectors within the clamping mechanism outside the box are not counted, which are these right up here. Okay, 2 internal cable clamps, these ones inside, is counted as one conductor. They take up space inside the box. Okay, internal cable clampings, whether factory or field supplied, shall be counted as one conductor. Now, where more than one size conductor is present in the box, the clamp shall be counted as the largest conductor. Now we're going to get into luminaire studs and hickeys. Luminaire studs shall be counted as one conductor. Okay, that's your A right here, this whole thing. And then one or more hickeys can be counted as a conductor. And If conductors of different size are present in the box, each one shall be counted as the largest conductor. Now, clamp fill or counting conductors. Clamp fill, one or more internal clamp counts as a large volume of the largest conductor. Supported fittings, studs, and hickeys counts as a single volume. We just mentioned that, but I wanted to go over that. And then each yoke or strap counts as a double volume of the largest connected to the device. Okay. Now we just went over this. This basically, I wanted to reiterate this. The largest conductor in this pile is going to be the one that's counted, and this pigtail is not counted. Now, counting conductors, again, we're going to be talking about equipment grounding conductors or bonding jump counters as one conductor, and that's of the largest in the box. If two identical boxes are ganged, its volume allowance is doubled. So if you have two boxes and you break and put them side by side to make one large box, then they add together. And then you get into the allowances. Again, we see this table. Again, it shows you this conductor size that you can count, how many square inches each conductor takes inside that box. That's what this table shows. Now, here we're going to do an exercise. Use table 314.16 alpha to determine the volume of a 4x4 by 2 1/8 inch. Now, there's a little kicker there. You're going to have to look that one up because we didn't talk about that one. Standard size box and the number of 12 gauge conductors that can be added if the box already contains 6 each 14 gauge conductors. Okay, so you're going to have to figure out the size, the volume that the 14 gauge takes up and the 12 gauge takes up. Okay, 14 gauge, you already know you got 6 of them in there. Okay, so you got to see how many more 12 gauge conductors you can put in that box. Okay, now the maximum volume allowance is hold on a minute, is let's see. Okay, what you need to do is here the volume and use. You already know that you've got 6 14 gauge conductors inside the box. So you find out what the size is, and the size. Hold on a minute. So the volume for a 4x4 by 2 1/8 inch box is 30.3 inches cubed. Okay, so we're talking about. So we multiply. We get the table. The 14 gauge is 2 cubic inches. So we multiply the 6 by the 2, okay, and then we'll put that aside, okay. So that's 12 cubic inches. Goes and subtract that against your 30.3 cubic inches. And then after you do that, your 12 gauge conductors are 2.25. So you take your 12 cubic inches away from the 30, and then you figure out, let's see, that should give you 18, and then so that 18, 6, you know, so basically what we're going to be looking at is, hold on a minute. So what we do is we take 14 gauge conductors. We got they're 2 cubic inches, and you multiply those by, you got 6 of those, that's 12 cubic inches. You subtract that from your 30.3. I'm going to forget the 3 for right now, and so that leaves us 18. Okay, so we divide the hold on a minute. Okay, our 12 gauge conductors are 2.25. So we divide that 2.25 into our 18. So that means we can add 8 12 gauge conductors into that box that already has those 14 gauge conductors in it. So that's our limitation on that. Now here's another one. We need to, again, the box is a 4x4 by 2.125, so we know that's 30.3 cubic inches. And the standard and the number of 12 gauge conductors that can be added if the box already has 6 14 gauge conductors. Okay, here's where we're getting into the answer of what we just discussed. Okay. See, we got in use, we have 6 times 2 equals 12 inches cubed. Now available volume, we subtract that 12 inches cubed away from the 30.3, and that leaves us 18.3. Okay, and so we divide that 18.3 by 2.25, and it gives us 8 conductors. Okay, so now we've got another one here that's I want you to example 2. This one's a you need to use both tables, 314.16 alpha and 314.16 beta, to determine a minimum standard size that 3x2 device box needed to mount a receptacle using 12 gauge conductors in a daisy chain. The EGC counts as 1, receptacles count as 2, the 12 gauge conductors 2 inch plus 2 in out equals, you got 2 in and 2 out, which gives you 4 conductors. So the total count is you have the lighting fixture counts as 1, and then you have the 2 conductors. So you have a total of 7 conductors. Okay. Now use the table to do this one again. Another example to finish this example up. You have 7 conductors, and then from the table you get the box, and 3x2 by 3.5 box, and that should give you what you need. I'm going to flip back a few slides to get to the table that we were looking at earlier, so I can point it out here. What we have is we have the 3.2 by 3.5, which is 3.5, and right behind me there is the 12 gauge, and it shows you can have a maximum of 8 conductors in there, and we're going to fill 7 in there, so we're good. Okay, so we have room for an extra conductor. I just wanted to show that. So now we're going to get into some other items. We're going to get into just showing where to read some of the box information. That's a plaster ring, and this is an extended box. Okay, they'll have markings on them. The plaster ring adds the cubic inches. It adds 7.5 cubic inches to whatever the box volume was. Say, for instance, it's had a volume of 30 cubic inches. Well, then you add that plaster ring on there, that adds another 7.5. Equipment markings. Equipment grounded, conductor fill, determine the number of conductors, cable clamps and connectors, your luminaire studs and hickeys, device or equipment, and then volume per conductor. That's all the things that we did, and the additional markings are used for helping us figure those out. Now I'm going to go over where you would see some of the markings on some of the boxes and stuff like that. Now in this page on your book, it shows the box, it shows the cubic inches, and this is the number of wires that you can have. Sometimes they'll put it on the box. Okay, there's the conductor size, and there's the number of conductors allowed in that box. Again, you know, if you've got these are all the conductors in there. The minimum number of conductors applies only if the box does not contain any fittings or devices. So in other words, if you have cable clamps in there that clamp inside, then those count as one conductor, and they would, take off the number that the manufacturer has in here if you put a clamp in there. Now your pigtails, they don't cut. The wire nuts are not counted in your conductor calculation. Now here we're trying to figure out your raceway fittings, connectors, and hubs are not counted. Each conductor originated outside the box, that is terminated or spliced inside the box, counts as one conductor. This box is pictured contains 5 conductors. If all of the conductors are 12 gauge, the box could hold a maximum of 9 conductors. That's from the table 314. There's the dimensions. It's a 4 by 4 by 1.5, so it's a 21 cubic inch box. Conductor that does not leave the box is not counted. Okay, a conductor that passes through the box without splice or termination, which is an unbroken wire, which is that black wire right here, okay, is counted as one conductor. Each loop or coil of unbroken conductor not less than twice the minimum length required for free conductor must be counted twice. Okay, and that's your E connector, which is down here where we can't see it. And so essentially that's a good little explanation of how to count the conductors. Okay, and then here we got into the clamps again, which we've gone through already, but I figured I'd put that in there again. And we'll see the lighting fixtures, the holders for the fixtures, those count as one. Okay, and then here's your receptacles and switches. And now a dual, regular receptacle with 2 outlets on it is going to count it as one. And now the duplex receptacle, the one on the left, that one counts as 2 12 gauge wires. The single pole switch counts as 2 14 gauge wires. Okay, so the 14 is, I think, 2 square inches, and so the 12 gauges are 2.25 square inches. Okay, so you keep that amount. And then now each mounting yoke or strap counts as 2 conductors. Okay, that's number C. Okay, so you got 2 conductors there. They're taking up volume in the box. Okay, now there's a note here. A note that the device or utilization equipment, if it's wider than a single 2-inch device box as described in the table 214.16 alpha, shall have double volume allowances provided for each gang required for mounting. Okay, what that means is basically if the box is used as a double box, if you mount them together, you can do that. Now, here we get into the volume per conductor. Okay, we talked about this on that table already, but here's a little chart that's in the book. It's kind of handy to have. Tells you the little, there's a 12 gauge, it's 2.25. There's a 14, it's 2.0, and then it's a 16 gauge is 1.75 cubic inches. So as the wire number gets higher, the wire gauge the size of the wire diameter gets smaller, which means it takes up less cubic inches inside the box. Okay. Now, the boxes have additional markings. Okay. You have the box fill calculations, dome covers, and canopies, and it splices inside conduit bodies. Here we have a nice little, and this goes over all of the conductors in a box. Okay, so here it goes through everything that it takes to figure out whether that box is legal. You have multiple entries into this box. So you have multiple conductors coming in and out. Okay, so the 3 conductors, all those spliced, count as 3 conductors. Two conductors that terminate in the box count as 2 conductors. That's the neutral and the chassis ground. Okay, those are the 2 wires. Now, 1 receptacle counts as 2 12-gauge conductors. An unbroken conductor counts as 1 conductor unless the conductor is not less than twice the minimum length required for free conductors. That's stipulated in 300.14. These 3 equipment grounding conductors that enter the box from 3 raceways count as 1 conductor. That's option F. Okay, that's those greens. And the 2 conductors terminated in the box is counted as 2 conductors. That's F. And then a single unbroken conductor is counted as 1 conductor. Now there's a little chart down here on the left. It goes through with your 12-gauge wires, 2.25, and then you know, basically that's the total. The minimum volume for conductors, the box is because the cover had 6 cubic inches, so that's why you get a little bit more room in here for conductors. If you look on the label behind you, if I could move my picture, that'd be nice. But behind on this box here, there's a label that says 6. If you look in your book, and it'll tell you that you can add that together and come up with total volume. And then you subtract all of the 12-gauge conductors, which are 2.25 each, from each from the total amount. We already determined that there was, and the volume for the box is 21 cubic inches plus the 6 cubic inches, it equals 27. And the maximum number of conductors looks like we can get up to 12 conductors at 2 times 2.25 is 27 cubic inches. And we have a 27 cubic inch box. So we're just right. We're legal, you know, with the receptacle and everything in there. We're good to go. That's a good explanation of what to expect. Okay. Now, dome covers, which we're going to do next. They're basically, if there's 4 or fewer luminaire wires, and they're smaller than 14 gauge, and the equipment grounding conductor can be omitted from the box fill calculations where they enter the box from a dome luminaire or cinema canopy. You know, the size of the dome cover or canopy is not a factor, and 2 luminaire wires and 1 equipment ground are not counted. Okay, so essentially the wires going in, you know, it's pretty much saying you don't have to worry about it. Just put a standard box up there and mount it properly, and you'll be okay, as long as you don't have a lot of conductors going through. Now, the conductors going through there, you still have to count those conductors. The feed and if there's an incoming feed coming in to feed that, and then you're going out to the next light fixture in the ceiling or something, then you know the incoming conductors and the outgoing conductors have to be counted. And now splices, taps or devices are permitted inside conduit bodies if the manufacturer durably and legibly marked the cubic capacity on the conduit. At least 6 inches of free conductor measured from the point in the conduit where it emerges from its raceway or cable or sheath, okay, shall be left at each outlet junction and switch point. There's a note here, the maximum number of conductors permitted shall be the maximum number permitted by the table 1 of chapter 9 for the conductor to which it is attached. Okay. The maximum number of conductors shall be calculated in accordance with 314.16 alpha and 314.16 Baker. For 4 14 gauge conductors, the volume of 2 cubic inch requires total volume of an 8-inch box, 8 cubic inch box. Okay. And so it's just something that to keep in mind when you see those A lot of those are going through like cinder block walls or something, coming in from the outside into a residence or into some, like somebody put a gazebo out on their property or something and they're running power there. They may want to do it that way, or they really should put a box, but some people do that for sprinklers, things like that. Now, general installation, you're going to get a securing cables to metal boxes, secure single gang non-metallic boxes. You're going to get into securing cables to non-metallic boxes. Boxes in combination, combustible and non-combustible materials, boxes, back-to-back boxes in fire-resistant rated wall. We're going to talk about some of that here. The next slide is going to talk about general installation, which is what we're talking about. Conductors must be protected from abrasion where entering boxes, conduits, or fittings. Now, if you see wires coming into a box and they're crimped and there's a possibility of the insulation being scrubbed away from there because they don't have the proper clamp on the box or something to that effect, then that could be a problem. It's always something to watch for. Sometimes on the Romex wire, if they stick it through the box and they cut the sheath off, and then you got your conductors come in and they may have cut that insulation around that conductor, and as that sheath is just coming into the box, you may see a little line on the conductor where there's somebody's knife may have hit it. So you have to watch that when you're taking the sheath off of like a Romex cable. Connection must be made between the equipment grounded conductors and a metal box by means of a grounding screw that should be used for no other purpose other than just grounding. That's your chassis ground. That's your green cable they're talking about. You can put that clamp on there. It's in the picture. Or there's some of the boxes have clamps that are, or screws that are inside the box, or sometimes I've seen them outside the box. Non-metallic sheath cable shall be secured within 12 inches of every cabinet, box, or fitting. Cables must be securely fastened to the metal box or conduit body that they enter. Okay, that's your clamps on the top or the bottom. That's what they're talking about right in here. Okay, that little clamp, and that's your Romex, is what's coming down that wall. And see how there's a clamp up here to hold it, and then they come down. That's usually about 8 or 10 inches, and then they bring it in like this. Okay. And unused cable or raceway openings in boxes and conduits, they must be covered. Okay. And most of the boxes, they have punch outs in them. But if you punched out in the wrong place, you need to put a little fill cap on it. And it's highly recommended. Again, here's another single gang non-metallic box installation. You see where you're 8 inches from that staple up top. And there's also a height off the floor, but we may cover that later. Non-metallic sheath cable not fastened to the box must be secured within 8 inches. Okay, these boxes don't have the clamps on them. They usually have openings in the back to kind of at a 30-degree angle where it comes in. But even if you do have a clamp on the box, it's always recommended to, because you're going to nail it up on the stud anyway. So I would keep that recommended wiring distance the same, 8 to 12 inches, at least 6 inches of free conductor measured from the point in the box where it emerges from the raceway or cable sheath shall be left at each outlet. Okay, so that way you have enough conductor there to put your receptacle on. And the cable sheath shall extend into the box at least 1/4 of an inch. That way you don't have exposed conductors not being protected by the sheath from the Romex sitting outside. You don't want just 2 conductors coming in or 3 conductors coming in through the box without the sheath on it. And all permitted wiring methods must be secured to the box unless the exceptions, and that's in 317. So now we're going to be talking about non-combustible materials. Boxes employing a flush type cover or faceplate in walls or ceilings constructed of non-combustible material, we're talking about concrete, tile, etc., shall be installed so that the front edge of the box is within a 1/4 inch of the finished surface. Now, boxes employing a flush type or faceplate in walls or ceilings constructed of combustible materials such as wood shall be flush. Okay, you can extend them out a little bit on concrete, but they need to be flush on like sheetrock, things like that. Now here we're getting into fire back-to-back receptacles in the same wall. Essentially, they want them, you can't put them in close proximity with fire-resistant rated walls. You need to separate them. And it's got to be at least 24 inches. Now, non-fire resistant rated walls, which is the third image here, you can put them in there. Okay, this is regular sheetrock. Okay, and that's explained in 300.21. Now, we just talked about this, the minimum depth, the surface extensions, how far out you're supposed to go with the boxes on concrete, and then gaps and spaces. Damaged or incomplete plaster wall. You don't want any opening. In other words, you don't want a lot of space around your boxes. So if you ever put one in, make sure you use a sheetrock saw if it's sheetrock, and take and draw an outline of the box onto the sheetrock, and then go inside the line, and then push it in. Some of those will have little clamps on them to hold them in there. Damage or inconsistent plaster drywall. Okay, we're going to get into box support of luminaires. Strain relief for flex cords, luminaire hangers, conduit stems supporting luminaries, device boxes supporting luminaries, mounted non-metallic boxes, your supported screws and draining. What we're going to talk about is the strain relief. It's basically a multi-conductor cord or cable used to support a box. It must be protected in an approved manner so that the conductors are not subject to a strain. Usually they have a wire mesh around them. The conductor goes through the middle of the wire mesh, and the wire mesh handles it. Now there are we have conductors that provide 220 to some of our equipment in our labs, and they use the cable that's specially made for that. Luminaire hanger, there's one there. It's section 314.27A subsection 2 requires an independent support, and such as a luminary hanger, it takes all the strain away from the cable. So whatever you're hanging must be hung, and not the weight of the luminaire being supported by the cable. Conduit stem supporting luminaires. An outlet box used exclusively for lighting shall be designed or installed so that a luminaire lamp holder may be attached. Boxes must be able to support a luminaire weighing at least 50 pounds. A luminaire that weighs more than 50 pounds shall be supported independently of any outlet box, unless the outlet box is listed and marked on the interior of the box to indicate the maximum weight the box shall be permitted to support. Okay. If your luminaire or light that you're putting up is over 50 pounds, then you got to put a cross brace in or some sort of thing to mount the box to. Other than that, you can mount them that way. I've seen a lot of lights mount that way. Device box supporting lamp holders. Now these boxes, an outlet box used for lighting shall be designed or installed so that luminaire lamp holder may be attached. Boxes must be able to support a luminaire weighing at least 50 pounds. Okay, a vertically mounted luminaire or lamp holder weighing no more than 6 pounds. So you can only go 6 pounds with these. Okay. On non-metallic boxes, which I wouldn't recommend, but anyway, supporting screws for non-metallic boxes must be mounted outside of the box. Okay, unless the box is constructed in a manner that prevents contact between the conductors in the box and the supporting screws. Okay, so you don't want a short. That's essentially what it's saying. Luminaire outlet boxes, ceiling suspended paddle fan boxes. We're talking about support still. Now, here we have boxes used at luminaire or lamp holder outlets, and the ceiling must be designed for the purpose and shall be required to support a luminaire weighing a minimum of 50 pounds. Every box used exclusively for lighting must be designed and installed so that a luminaire may be attached. An outlet box can support a luminaire weighing no more than 50 pounds unless the outlet box is listed and marked on the interior of the box to indicate the maximum weight the box shall be permitted to support. Okay. Ceiling fan is a little different. Okay, we're going to get an outlet box or outlet box system shall not be used as the sole means of support for a ceiling suspended paddle fan unless the box is 1. Listed, 2. Marked by the manufacturer as suitable for the purpose, and 3. Supporting a ceiling suspension paddle fan weighing 70 pounds or less. Fan outlet boxes or outlet box systems designed to support ceiling suspended paddle fans weighing more than 35 pounds. The required marking must include the maximum weight that can be supported. So in other words, what they're saying is you need to make sure that you get a box that's rated, okay, and that can support these. I've seen some of these where people just mount it to a box that's sitting there inside the ceiling, and the only thing that's supporting the box is a bracket that they put up there or something, and sometimes causes problems. Especially if the fan moves around a lot, eventually it'll fall. Junction and pull box sizing. You got straight pulls, angle pulls, U-pulls, raceways entering opposite, and removable covers. So 4-gauge wire and larger, under 60 volts. That's what we're talking about on straight pulls. 2 raceways, the trade diameter of the largest raceway. Okay. Multiple raceways, no additional length for additional raceways. 8 trade diameter, largest raceway. Must be accessible without removing part of the building. Now, a straight pull, the box calculations for 4-gauge and larger conductors under 600 volts are performed based on the size and number of raceways. So you take the diameter of the raceway and how many there are entering the box and leaving the box. Boxes of conduit bodies containing straight pulls are sized according to the largest raceway entering the box. The length must be at least 8 times the trade size. Okay, when they talk about that, it's a metric designator of the largest raceway. A box width. Now there is a note here. Use the trade dimensions that is applicable to the installation. For example, if millimeters or centimeters are needed to size the junction or pull box, use the metric designator in millimeters instead of the trade size in inches. The junction box is needed for a straight pull with 2 metric designators. 53 raceways. A 2-inch trade size raceway has a metric designator of 53 millimeters. Calculate the minimum length by multiplying the metric designator by 8, and the minimum size pull box required is 424 millimeters or 42.4 centimeters. Okay. Now, here we have, they use the designated, they use 8 times the millimeter size is what they're talking about. Now down on the bottom right, they show the straight pull, they show a calculation of, they multiply it by 8. The raceways, you have 2 of them at 2 inches each. Okay, so that's 16 inches. 16 inches is 42.4 centimeters, I think is what they're getting at with that note. So you need to have room to pull the conductors through, so you can have a box at 16 inches. Now, do this next one. The box width must be large enough to provide proper installation of raceway or cable, including the lock nuts. If you look at here, we're talking about the little, what this is threaded, and they have a little nut that goes on the end of this piece of conduit, or raceways they call it. It's also called conduit. And the box depth must be large enough to provide proper installation of raceway or cable, including lock nuts and bushings. So you got to get in there and tighten them down. No requirement specifies the depth of the box unless raceways entering from the back of the box. So if they're coming in from the side or the top and going out the bottom, if they're coming in the top, then the box depth is not really a big deal. But if you got some coming out the back, then yeah, probably got to decide on your depth. Now here we have another example. Okay, multiple raceways. Now the length must be at least 8 times the trade size, your metric designator. Okay, so 8 times, if it's 2 inches, which is usually you want the largest one, and you got 3 different size conduits or raceways coming into the box. So you usually pick the largest one, which is the bottom right, which is a 4-inch. Okay, so you take 4 times 8, which is 32 inches. So you have to have a 32-inch box, because you're figuring, then you also have to, well, I won't get into that. Your box calculations, you may need to know that. There's a caution here, except as permitted in 250.112 section I. All metal boxes shall be grounded and bonded in accordance with parts 1, 4, 5, 6, 7, and 10 of Article 250. And so again, we make sure everything's grounded. If there's any broken connections in here that you need to, pigtail together or something like that, then you, a lot of times this is a pull box where you're going to be pulling cable from one direction to another. And now we're going to go into another pull situation. U-pull or splices of multiple splices. They're supposed to be splices of multiple raceways. Here we have where splices or where angle or U-pulls are made, the distance between each raceway entry into the box and the opposite wall must be at least 6 times the trade size of the larger raceway in a row. This distance is increased for additional raceway entries in the same row on the same wall of the box by the sum of the dimensions of all other raceways. This is designated in 314.28 alpha subsection 2. Now, if you look on this drawing here, you have the number of raceways. Okay, trade size of the largest raceway is 4 inches. And multiply that by 6, and then you have the 3 and the 2-inch raceway, and that's 29 inches. That's for your Y dimensions. Okay, that's just the depth or the height of the box, not the depth. Okay, now the X dimensions is the same thing. The largest one here is only 3 inches coming in. So you take 6 times 3, plus the other 2-inch conduit or raceways gives you 22 inches. So the width is 22 inches and the length is 29. So you have to find one that's within, they usually got 24 by 30s, 32, something like that would be good enough to fit that. Okay. All pull box, junction boxes, and conduit bodies must have covers that are compatible with the box or conduit body construction and must be suitable for conditions of use. In other words, if it's outside, it has to be a sealed box. If the box is an outdoor box instead of a box that's going to be inside. It's a little bit heavier gauge metal. The caps are a little different for popping out the holes in the box. Now, so that would be how you tell on that box. Now here you have straight pulls with splices. This is basically those little connectors in the middle. They have little screws in them. And you got a little pocket screwdriver that can tighten those down. Those are, based on the gauge of wire you're going to be working with. Where a junction box contains 4-gauge or larger conductors that are spliced, and the box contains only straight pulls, compliance with 314.28 A Section 1 and A Section 2 is required. Perform both the straight pull calculations and the angle pull calculations, and then compare the results. The minimum dimension will be the larger of the two calculations. So essentially, here we're showing the calculation for the horizontal, which is your X dimension, and then your vertical. Well, there you see angle pull for horizontal is the 18 inches, which is on behind my picture, and then the vertical is the one at the top, which is 16 inches. And basically, all the conduits going in are 2-inch conduit. So you use a designator of 8 to 16. Here you're not using the 6 designator, you're using the 8 because they're all the same. Now we're going to get into some angle pulls, raceways enclosing the same conductors. The distance between raceway entries enclosing the same conductor should not be less than 6 times the trade diameter of the largest raceway. This provision is applicable if the raceway's entries are on different walls. Okay, because no other raceways entering on the same wall of the box, no additional raceway diameters are added. Okay, so you're figuring the size of this box, and the minimum dimension required for this box is a 12 by 12. The distance between the raceway entries must not be less than 6 times the trade size. Okay, so it's the 2-inch. So our distance between, this here and this raceway cannot be any less than 12 inches. Well, the first example, it shows it coming in halfway to the box. Well, that's not going to make it. It's got to go way up here. That's what this box right here behind my picture shows. Okay. The 2 raceways will enclose the same conductor. So essentially it's going to be going, you got to have a 12-inch box diagonally. So you can put it in the upper left corner and coming in, one entry is on the left corner, top left corner, and the other exit or entry is on the bottom right corner of the box, of a 12 by 12 box. Now this one here is angle pull, multiple rows. Here it goes into the calculations where multiple rows of raceways enter a box. Calculate each row separately. Use a single row that provides the maximum distance. Create an imaginary dividing line separating each row and perform each row calculation in a separate box. Okay, so you have separate boxes and then you combine them. So angle pull for Y dimension, you're using a trade thing, you're using, since there's multiple raceways here, you're going to have multiple you're going to use the designator 6 instead of 8. You're going to have multiple calculations here, because what you're going to do is look for the largest one in that row, and then add, times that by 6, and then you add all of the other conduits in that row together. So if you're looking at the example for the Y pool, the first one, the front section is 3.5 by, so you got a 4-inch conduit. That's the back row they're doing, and back top. This calculation right here is working on this row back here. Okay, so they're taking the 4, multiplying it by 6, and then adding these two together, and it gives you that. Then this one should be taking the largest one here, which is your 3.5, multiply it by 6, and then add all these together to give you this number. And then here you're doing the same thing. You're taking multiplying by 6, your 3.5, and then well, this one here is doing the back row. They do the back row first. I always do the front row first, but they're doing the back row here, 4-inch, and then add those together. 6 4 is 24, and then these two gives you the volume. And then this one here, you take, I think it's a 3.5 inch times 6, and then you add these other 4 conduits to get you the volume. And so then you add all that up. And here, yes, it's kind of like looking at 2 separate boxes. Okay. And once you do that, then you add them together to get your depth. Now, this is a U-pool with 2 raceways. Again, you have a distance apart. There's some calculations down here that they're 2-inch raceways. You use the 6 designator, and then you add the second one, and that gives you 14 inches for your height. Okay, and then basically you got 12 inches for your X. Okay. This is your Y, and that's what this one was. Now, coming into an inner raceways outside removable covers, this here is essentially the same thing. You're doing the largest raceway times 6, and so there's no other raceways. Then it's 18. So that's the depth and the height of it, your Y, and then your X, your angle where the box is coming out. The other 2 raceway, coming out of the box is got to be 18 inches diagonal. And we've already seen that slide. Now this is what we did. We just talked about all this. And here's just basically, if you have anything that's not marked, that's not listed, you look in Chapter 9 or look at Chapter 314, Article 314.28. So now limitations apply to the size and number of conductors permitted in the box. One strap or yoke counts as 2 of the largest conductors connected to the device. Non-metallic boxes may list the maximum number of conductors permitted in the box. Plaster rings, raised covers, extensions, rings, or devices if the conductor body is durable and legibly marked by the manufacturer with the volume. The maximum length of a free conductor, 6 inches, is measured from the point in the box where it emerges from its raceway or cable sheet. Except as permitted in 250.112 Section I, all metal boxes shall be grounded and bonded in accordance with parts 1, 4, 5, 6, 7, and 10 of Article 250 as applicable. Boxes and conduit bodies must remain accessible, and suspended ceiling boxes can be secured by support wires that are installed in addition to the ceiling tile support wire, grid wires. You don't want to use the same wires. Where boxes enclose 4-gauge or larger conductors that are required to be insulated, different calculation methods apply to straight pulls than to angle pulls. There is a maximum distance required between raceways enclosing the same conductors within a pull box or junction box. Conduit bodies may not allow the same size number of conductors as in permitted in conduit or tubing that enters the conduit body. This is telling us conduit bodies may allow the same size number of conductors as is permitted in the conduit or tubing that enters the conduit body. In other words, it's telling us that you got 12 gauge conductors coming in there, so you're allowed to have, say, 8 of them in there if it's I think we figured it was 31 cubic inch. And so anyway, this video has been kind of long. You may want to stop it and start it a few times, kind of go through things. It's pretty dense with a lot of calculations and information in this chapter. So good luck with it. And if you have any questions, don't forget to email me, Joe Murphy, at jmurphy@trcc.edu.